Hello everyone, welcome back. Today we will look into the Leetcode easy level problem called implement queue using stacks. So let's understand the problem statement. So the problem statement says we need to implement a first in first out queue using only two stacks. So we'll need to use the two stacks and make them behave like a queue. The implemented queue should support all the functions of normal queue like push, pick, pop and empty. We need to implement the myQueue class, and it should have this methods like push method, which will help to push the element to the back of the queue, pop method, which will remove the element from the front of the queue and return it, pick method should return the element at the front of the queue, and empty method should check whether there is any data in a queue or not. Along with these conditions, there is an extra condition mentioned here that all the operations of that queue should have the time complexity of amortized O of 1. While understanding the problem statement with an example, we'll see what does this mean, amortized 1 time complexity. So let's start. So let's say this is our queue. Queue contains two pointers. One is a front, which points to the front of the queue, and one is rear, which points to the end of the queue. So how does queue behave? So when we add element to the queue, it adds to the end of the queue and moves the rear pointer. And when we remove the element from the queue, it removes the element from the front of the queue and moves the front pointer. And when we do the front or when we do the pick, it basically gives the first element of the queue where front is pointing, which is 15. So now we need to implement the queue using a stack. So let's say we have given this stack which contains this 3 element and top is pointing at 8. So when we do the push operation on a stack, it should behave like a queue and add that element to the end of the stack. And when we do the pop, instead of removing the element at the top, it should remove the element which was added to the stack first, just like a queue. And when we do the pick, it should give the first element of the stack, which is 10, like how the way queue returns the front element. Now, in this problem statement, we have given a two stacks, stack A and stack B. Now, let's understand how each operation we can perform like a queue using these two stacks. For example, push. So in a push, when we add a new element in a queue, the new element gets added to the end. So similarly, in a stack also, the new element gets added to the end. So when we do the push, it is actually just adding the element to the end of the stack. That's why the complexity here is O of 1. Let's understand the pick operation. So what is meant by pick operation in a queue? The pick operation in a queue is that give the front element of the queue or the first element which was inserted to the queue, which is 10 here. But now in a stack, we can't give this 10 without moving these elements. So we need to move these elements to the stack B and then give the top element of the stack A, which is the peak, basically just like act like a queue. And once that peak element is returned, move all the elements back to stack A. Right? So this is how we can support the peak operation for queue using these two stacks. And because we have to move all the elements from stack A to stack B, so n is the number of elements, so that is why the time complexity is O of n. Let's understand how the pop functionality will be supported. Similarly, when we do the pop in a queue, it returns the front element or the first element which was inserted. The first element inserted here is a 10. Now, the same way how we did for pick, we have to remove these elements first and move it to the stack B, and then remove the first element which was inserted, and then move back all the elements back to the stack A. Now, in the pop operation also, to support it as a queue, we need to move all the elements in a stack. So that is why the time complexity is O of n. N is the number of elements in a stack. Now, there is one condition which was asked in a problem statement also, that we need to make sure that all the operations of the queue, push, pop, pick, and empty, have a amortized O of 1 time complexity. So, but we saw that pop and pick operation have a time complexity of O of n. How to optimize the pop and pick? So whenever the pop operation is performed, instead of basically we'll move that elements to the stack B, but instead of moving back from stack B to stack A, we can keep it in a stack B only. And next time when the pop operation will happen, we can give the top element from stack B only, because once this first element is removed, the next front element will be 15 only, because this was the first element inserted and this was the second element inserted. So that is how we can give the top of the stack B. And next time also we just need to give the top element from stack B. So one time it is O of n, but next time the pop operation will be O of 1. So if the stack B is empty, then move items from stack A to stack B. If the stack B is not empty, then pop the top element of the stack B, because that was the first element pushed to the stack A. Now this way we don't have to move all the elements for each pop operation. So we can see first time only we have to move the elements from stack A to stack B. Next time we can just give the top of the stack B. So basically the stack A is acting as an input stack where we can push the elements, and stack B acting as an output stack from where we are removing the elements. So now we can see that the time complexity became the amortized O of 1. Why amortized means that average O of 1. So why? Because when the stack B is empty, then only we need to move elements from stack A to stack B. In that case, only the complexity is O of n. But when the stack B has some elements, the time complexity will be O of 1 only, because we need to give the top element only. So that's why on an average, the time complexity is O of 1. Amortized means average. Average time complexity is O of 1. Similarly, we can do the for the pick as well. Like if the stack P contains elements, just give the element at the top. If it does not have any element, then move the elements from stack A to stack B and then give the top of the stack. Now let's understand the solution. So this is a Java implementation. So as mentioned in a problem statement, this is our myQ class. We have declared two stacks which will contain the integer value. One is the input stack, which is nothing but our stack A, which will basically receive the input, which is push operation. And another one is output stack, which is nothing but our stack B, which will give the output, basically pop or pick. And then in a constructor, we are initializing these two stacks. So whenever a new element comes, the push element X to the back of the queue. So we'll insert that new element to the stack A, end of the stack A, which is O of 1 now. And then whenever the pop or the pick operation comes, so in pop, we need to remove the element from the front of the queue. Now we need to do the shift from stack A to stack B. But if you see the logic of shift stacks, we will shift only when the stack B is empty or the output stack is empty. If empty, then only shift from input to output. And once this shift is done, then in case of pop, return the output dot pop, or in case of pick, return the output dot pick. So this way we are achieving the average O of 1 time complexity, or we can say amortized O of 1 time complexity. And empty condition is simple. If both the stacks input and output doesn't have anything, then return true. It means that we don't have any data. And shift stacks is used to move the elements from stack A to stack B only if the output stack is empty or stack B is empty, as we understood in the explanation. So as we understood, for each operation, because we are moving only when necessary, that's why each operation is having on an average O of 1 time complexity. Let's submit it. We can see this is successfully submitted. So hope you understood the explanation and solution. If you like the video, please share and subscribe. Thank you so much.